Hello girls, I hope you're staying safe at home. To continue with the chemical changes and reaction chapter, today we are going to discuss displacement reaction. Now when we talk about a displacement reaction, we are talking about a chemical change in which a more active element displaces a less active element from its salt solution. Children, before I continue, let me tell you there is a mistake in this. So I want to show you the corrected form. Now see, AB is a compound where A is the positive radical and B is the negative radical. And then there is another element C which is positive. Now, when we look at A and C, the positive radicals, you will see that C is more active and A is less active. So, in this reaction, what happens is C will come to take the place of A and A will be displaced out. So, here, what will you get? We will get CB plus A. Okay, so a more reactive element displaces the less reactive element from its compound. So now moving on to the experiments to show displacement reaction. The first experiment is we take a solution of copper sulphate. If you remember, what is the color of copper sulphate? It is blue in color. We take a copper sulphate solution, we take it in a beaker. Then we add a few pieces of zinc, which is a metal, and then we stir it with a glass rod. You will see that the blue color of the solution gradually fades, means it starts disappearing, and soon you will see it turns colorless. And at the same time, you will see reddish brown particles settling down at the beaker. Okay, so why is this happening? The reddish brown particles is of copper because it is solid. So in this reaction, you will see that zinc is more active than copper. So it will displace copper. Copper will come out and it will be released. Okay, and zinc sulfate will be formed, which is a colourless solution. So in the question you will get a blue colored solution is taken in a beaker and a few pieces of metal is added to it and stirred. Then after that the question will come to you. What will happen to the color of the solution? What is formed? Then you'll have to write down the chemical reaction. The next experiment is in a test tube, we take some dilute sulphuric acid and in it we put a small piece of magnesium ribbon. Again, magnesium is a metal, okay? Ribbon means a very small piece of flat magnesium piece. Now, brisk effervescence takes place. Effervescence, had I mentioned it before? Yes, I think I had mentioned this before. Effervescence means like continuous boiling. Like when you open a Coke bottle, you see the bubbles coming out quickly. That is known as brisk effervescence. I had told you before also. And what is released? Hydrogen is released, hydrogen gas. So brisk effervescence is used when hydrogen is released. And what is the test for hydrogen? It burns with a pop sound. Very important. When does it burn with a pop sound? When we bring a burning matchstick near the mouth of the test tube. And of course, the equation magnesium plus sulphuric acid, magnesium will displace hydrogen. Hydrogen will be released with brisk effervescence and it burns with a pop sound when we bring a matchstick near its mouth. Now, next experiment is we pass chlorine gas through a solution of potassium iodide. The solution is colourless. Which solution is colourless? Solution of potassium Iodide is colorless. It turns yellow-brown. There, again, there is a change in color. So you must remember these colors are very, very important, because what is the color of iodine? It is yellow-brown. So this is the equation, potassium iodide. When it is passed, when chlorine gas is passed through potassium iodide solution, chlorine will displace iodine, okay, and then iodine will be formed, which, what is the color? It is yellow brown in color. Okay, now from these examples which we just discussed, you will see that metals, zinc is more active than copper, magnesium is more active than hydrogen, and in non-metals, chlorine is more active than iodine. Okay, so by taking similar examples, activity series was prepared. Okay, so this is the activity series of metals and non-metals. Okay, non-metals, fluorine, chlorine, bromine, iodine. Most reactive is fluorine, followed by chlorine, bromine, and iodine. Okay, and metals, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum. And children, let me teach you a way by which you can keep this in mind. That is the activity series. Kind nations can manage all zones, freeing public health, accumulating huge amount of gold, that is Au, and platinum. So this is how you can keep the activity series in mind. Now supposing if there is a reaction zinc sulphate plus copper, what will your answer be? You look at the equation and you'll think copper sulphate and zinc. But here there will be no reaction, because let's go back to the activity series and see zinc is here and copper is here. That means zinc is more active and copper is less active. So copper does not have enough energy to displace zinc, because zinc is stronger, because it is higher in the activity series. So this is your displacement reaction.